Okay, another type of op-amp circuit is op-amp integrator. As its name implies, the op-amp integrator is an operational amplifier circuit that performs the mathematical operation of integration. That is, we can cause the output to respond to changes in the input voltage over time. As the op-amp integrator produces an output voltage which is proportional to the integral of the input voltage. Suppose as we replace the resistor of feedback by capacitor, so that we can call it integrator. So in the previous, during inverting, non-inverting, summing, differentiate type of op-amp, the feedback is sort of a resistor. Now replace that resistor when by capacitor during this feedback, we can call it integrator. So how to determine V out during this circuit or during this integrator op-amp? Now, as you see, our V in through resistor enter to the inverting terminal. Also, our V out back through a capacitor to the invert terminal. So, when you see V in through this resistor to invert terminal, again through this capacitor to the output. So by applying KCL method, V in or I in equal to IF. So I in is the same with IF according KCL method or by applying KCL method. So IF is that is current of the capacitor. So that means I in equal to IC because IF replaced by IC. You know IC during charging discharging of capacitor, if you remember during fundamental course when to determine IC becomes capacitor of dVc over dt. So d of Vc over d of dt means that's charging means of C of V. So IC becomes d of charging over d of t. That is means IC becomes d of q. That means C of dVc over dt. This is current sort of capacitor change of voltage over change of time. Now, so this value means IC. So I in, when you first simplified, I in V in sort of this resistor enter to the inverting terminal. So V in minus V inverting over R. Then IC charging of CF d of Vc over d of dt. So d of Vc from inverting through this capacitor to the V out. So this means Vi minus V inverting over R becomes CF d Vc becomes V inverting minus of V out over dt. So as you know, the non-inverting terminal of the op-amp is grounded. So V non-inverting becomes 0 because it's grounded. The rules of op-amp circuit analyze V non-inverting equal to V inverting. This becomes 0. So replace V inverting by 0. So Vi minus V inverting when replaced by 0 over R, this becomes C of feedback capacitor d of 0 minus V out over d of t. So this means Vi over R becomes C of F d of minus V out over d of t. This becomes, when it is rearranged over R, that's equal to minus of Cf d of V out over d of t. Then now simplified dV out over dt. So this means 1 over minus Cf when you cancel, multiply by Vi over R, d of V out over d of t. This becomes 1 over R of Cf, that is negative because that's minus, over Vi of t. So when in both sides we take integration, so we can get V out. So in both sides, when you take integrate, we get V out. So V out becomes minus 1 over R feedback resistor, the integration of infinity over t, Vi of t dt. So this is our V out during integration. We can get V out during integration it looks like this one. That's to clear, V out becomes minus 1 over R of Cf, the integration of from minus infinity to t, Vi of t d of t. So now V of t becomes minus 1 over R S, that is resistor input Cf, the integration of minus infinity to sort of t Vst of dt. So integration is a process of continuous additions. So where they apply integrator, the application of integrator is ramp generator. Integrator responds to a constant voltage. This ramp generator very useful in timing circuits. What's the integrator respond to? A square wave, useful for waveform generators, called a ramp generator. So that means input signal that is square wave, then the output becomes sawtooth or triangular wave. So op-amp behavior on triangular wave input integrator is well used for voltage to frequency converters. So this is about the integrator. The next we'll see about differentiator. Hello everyone. Now today's class about op-amp differentiator. An op-amp differentiator is an op-amp circuit that has an output voltage proportional to the instantaneous rate of change of the input voltage. The differentiator gives an output voltage that is proportional to the rate of change or slope of the input voltage. So, to prevent magnifying high frequency noise, series resistance R is included in the circuit. So, our feedback of the op-amp is a resistance. Our applied voltage with the capacitor. So, what does mean when you applied a DC signal, when you applied a DC signal in the input, our output becomes 0. Our output becomes 0. Why? Because the signal is not at all changing with the time. The signal is our DC source, no frequency in our DC source. So our output in the op-amp becomes 0 because the signal is not all changing with the time. Again, when you applying a square wave, when in our input is square wave, in the output becomes, will get a spike signal. That means with fast raising time of this input, sorry, so we get in output spike type, fasting of timing transition. So what does mean? The differential circuit can be used to find high frequency components of the input signal, or we can use this differential circuit for aging detection purpose. So differentiator op-amp is mostly used for aging detection purpose, So to analyze our op-amp, how to get V out according to the rules of golden rule, virtually grounded, V inverting and V non-inverting, sorry, virtually ground. So our inverting becomes 0. So at this time IC equal to IF. So IC means charging of discharging of this capacitor. So C of dVc over dt equal to, what about IF? That V inverting becomes 0 because virtually grounded with non-inverting. 0 minus of V out over RF. So this means when you simplified the circuit, C of dVc over dt equal to minus V out over RF. So we get from this one Vc minus C of dV in over dt, it becomes equal minus V out over RF. So to find V out, simplified, V out becomes minus of RF times C d of V in over dt. So simply minus RF capacitor of d of V in over d of dt. This is our V out in integrator. So the gain of our op-amp depends on the feedback resistor and the capacitor. So when you're applying the capacitor in AC circuit, that depends on the frequencies. That means capacitive reactance XC becomes 1 over 2 pi FC. So the gain of our op-amp, it depends on the frequency of the inputs. So in your PowerPoint, that V out becomes minus of feedback resistor capacitor of the input times D of V source, that is V in over dt. So an amplifier can utilize the relation between charge and currents. So what I said, differential application is mostly purpose used for edge detection purpose. So it differential response to a square wave. The differential is good at detecting edges or transitions, very useful in digital circuits. So mostly applied and differentiator op-amp is in edge detection purposes. But don't forget, don't confuse the differentiator with a differential amplifier. That is a differential is that is an aspirator. So this is about a differentiator. So a differentiator is depend on the frequency, that is directly proportional with the frequency, that is sensitivity to the frequency. So thank you.